Now let's discuss algorithms. Now we're just some steps closer to pseudocode, as that will be the full swing of the paper two. And let's move on to the algorithm. So basically, algorithms. What are algorithms? Algorithms are basically a procedure for conducting any task. It may or may not be related to CS after all, but it is a general procedure. It is a breakdown of a task into multiple steps that you might follow to execute that particular task. Now, what is an algorithm by definition? A step-by-step procedure or set of rules to solve a problem. As I said earlier, it provides a clear sequence of instructions to achieve a specific goal. So now, how are algorithms relevant in CS paper 2? We need to work on that. And so in CS paper 2, there will be multiple types of questions that can be asked regarding algorithms. Number one, you can be asked to convert an algorithm into a pseudocode. For that, you must know what an algorithm is. Pseudocode. Now, apart from that, you can be given a task to write an algorithm. Now, for example, it can say uh, you need to write an algorithm which provides the detail for solving for sorting numbers into even or odd. Now, using structured English, algorithms are always written in structured English, which means you are not supposed to write any sort of code. You're not supposed to write any sort of syntax. You're not even supposed to follow pseudocode. So you just need to provide instructions. For example, if you are supposed to use an if statement, say if input is divisible by 2, divide classify it as uh, even. So that's pretty much how it works. You are not supposed to give all the necessary procedures that you are going to follow. What you're supposed to do is to provide instructions to what to do. Well, you need to provide instructions regarding what do you need to do. For example, recipe for baking a cake. Now there is no code in recipe for baking a cake. There is no code. There is no pseudocode regarding it. So basically, algorithms assess your logic, what logic you're using. Then directions on a map, sorting a list of numbers. Lastly, I was going to ask, so it can also ask about like features of algorithm. Which algorithm is a good algorithm, which algorithms are bad algorithms, and like how are you supposed to write an algorithm. So this is all that can be assessed. And apart from that, it can ask definition of algorithm for a mark, or it can also give you an algorithm and convert it to a pseudocode. It can also provide you a pseudocode and convert it into an algorithm, or it can give you an algorithm and say break down it into more simpler algorithm. So a good thing about algorithm is that it must break down a problem into multiple problems. So if it has given problems and it has some problems in it, you can make multiple algorithms for it and join those algorithms to make a good algorithm. Now, what are the characteristics of a good algorithm? So well-defined inputs and outputs should take valid inputs and procedure correct outputs. So you need to understand that now we're talking in CS terms, and we should be very familiar with inputs and outputs. So a good program need to execute all the necessary processing it needs to do. For that, it needs an input and then an output. So certainly, if you're inputting one and then your program is to check whether it's even or odd, your algorithm should give clear uh, output that it's even or odd. Now, what should you do to write an algorithm for that? Okay, so number one, take input, divide input by 2. If the result is a whole number, output even, else output odd. This is how you write an algorithm. There's no code in it. No computer is able to understand what I've written, but a programmer will see all this and it can write a 3-line code into VS Code or stuff. Now, definiteness. Each step must be clear and unambiguous. As I said, if this, else this. Now, that was a if and else statement. We'll learn about that later, but this was very definite. I did not say that if it is not real, then do this. And if you do not specify that, for example, if it inputs in if an input is 1 for or else input is like a b or something, now you cannot, your algorithm cannot specify that. So that was a shortcoming of my algorithm which I briefed. So you must contain all the definite possible steps into the algorithm, that you also need to output error or something like that. So effectiveness, each step must be basic enough to be executed easily. That's pretty much understandable. Finiteness, the algorithm must eventually terminate. So, as I said, 1 is either divisible by 2 or not. If it is, output even. If it is not, which is it is not, so output odd. So, that's how algorithm ended. Now it won't perform again. Generalization. It should work for different input cases. So now, yeah. So for an algorithm, you can say like ONE1 is 1. 1 as an integer is 1. So this is multiple characteristics of a good algorithm. We'll deep diver will dive deeper in this whole algorithm thing with pseudocode and catch you there.